So for 3-66 delta, it says use the standard paper and pencil method for multiplying 2 3/10 by 1 4/10. So again, it's the same problem as we had above. Do not use a calculator. Where do you see the numbers from this standard algorithm in the generic rectangle? So what we're doing is we're going to use the standard paper and pencil method, which really is the standard algorithm for multiplying decimals. And again, algorithm's just a fancy word for saying method. And this is usually the one that if you have an adult who loves and cares about you or someone who's older who's helping you, this is the method that they learned. And it's also probably the first method that you learned to multiply by. So again, we're looking at delta. That's this guy right here. So the rule is that when I'm multiplying a decimal by a decimal in using this method is, I don't worry about the fact that it's a decimal until the very end. I treat it as just a regular whole number multiplication until I get to the very, very end. So I pretend that I have 23 times 14. So my first step that I do in the standard algorithm is just like if I had 23 times 14, so I multiply my ones placed together. So I have 4 times 3, which is 12, so my 2 goes down here, and my 1 regroups up top. Next, I multiply in the next place value over. I multiply my ones times my tens. So I have 4 times basically 20, but I count it as 2. So that's 4 times 2 is 8, plus what my extra that I regrouped is 9. Okay, so the next 2 steps typically is the spot where if a student was going to make a mistake, this is where they're going to make a mistake. So the first one's kind of little, but it has, like I said, I've had a lot of experience seeing this, is that they don't cross out or eliminate their regrouping. And so they end up regrouping again when they shouldn't. The other thing is that when we do this, something that may not have been explained to you when you learn the standard algorithm the standard way is that I'm multiplying by ones here. I'm multiplying by my ones place. Now I'm moving over into my tens place. So because of that, I need to have a placeholder because I'm no longer just doing 1 times 3, even though that's what we say, but I'm really multiplying 10 times 3. So I should have 30. So I should not have anything in this particular spot. Many students are going to write a 0 right here because you've been doing that since 4th grade, and that's just fine. I personally use an X to show that I have used a placeholder instead of a 0, where I don't know the difference if I actually multiplied them. I just have to do a little more work, and I've always done it this way. This is just the way that I personally learned to do this. You absolutely do not need to have an X there. I just do it so that I know that that's a placeholder. Still has a value of 0, but that's just the way I do it. So now I have 1 times 3, or 10 times 3, if you will, which is 30. Right, so you can kind of see my 30 right there. But it's actually 3, so 1 times 3 is 3. And then I have 1 times 2 is 2. So now my next step is to add them all together. So I have my 2 plus my 0, or my placeholder, is 2. I have my 9 plus my 3, which is 12. So I have my 2, I regroup the 1, and now I have 2 plus 1 is also 3. Now is when I look at my decimals. This is now when I will place my decimal. So I have 1 digit that is to the right, 2 digits that's to the right in my factors. So I'm going to move my decimal 1, 2 spots to the left so that I also have 2 spots to the right here. And it's good because this matches my answer from up here, and that works out great because it's the same problem. Now what they want you to do is they want you to figure out, see where you can see what we have in the standard algorithm and in the generic rectangle above. So as we look at these, what steps do we see together? And so what I'm going to do is I'm going to try to differentiate maybe with a few different colors so that we can see it. Hopefully you can see it well on here too. So I have on this one right here, I did 3/10 times 4/10. And I did that part of the problem right here. I have 3/10 times 4/10. I also had 3/10 times 1/10, or excuse me, 3/10 times 1, excuse me. And that was right here where I have my 3/10 times my 1. Oops, you can't see, my bad. 3/10 times 1, just like we had our 4/10 times 3 right here. I also had my 4/10 times 2, and that was right here in this part. And lastly, we had our 2 times our 1, and that is right up here. So all of our parts of the problem are represented in each. It's just what makes sense and how you want to deal with it. I'll be honest, standard algorithm, I try to avoid it if I can. I always have to write something down. I can't just do it in my head. Whereas I can do something like this, a partial products method or a generic rectangle without writing all that down. I can do a lot more of it in my head. And so if I don't have a calculator, I'm actually more apt to do something similar to this than that personally. But again, that's a choice. Once I know how to do different methods, then I can use the one that works best for me and my brain. Some students will love this until the end of time. That's the one that they learned first. Some students are not accurate with this one. And if you're one of those students who struggles with the standard algorithm for it to be accurate, I implore you to reach out and to try to use some of these other methods. Even with whole numbers, you can do it. Even with fractions, you can do it so that you're able to be more successful. There's more than one way to do it, which is what I really love about these types of lessons, is that you can find the one that works best for you, or do like I do and pick and choose when it would be best for it, because that's really big. So we've had 3 methods to be able to do this. We used our model on our resource page where we shaded vertically, we shaded horizontally, and then where it was double shaded was our answer. We used a generic rectangle where we decomposed or broke apart problems on the numbers, made simpler problems, and then added or recomposed them back together. And then we had the standard algorithm where we treated it like whole numbers and then only dealt with the decimal at the very end. Please let me know if you have any questions.